Hello, for the first problem I did for week 6A, I did question number 1, and it states, in an ultra-low temperature experiment, a collection of atoms enter a special state called Bose-Einstein condensate, in which the index of refraction is 1.68 times 10 to the 7th. What is the speed of light in this condensate? So, first of all, for this, I had to use the index of refraction equation, which is n equals c over v, and c is the speed of light in a vacuum. Its SI units is meters per second, and it's a constant that we're given, so it would be 3.00 times 3.00 times 10 to the 8 meters per second, and that's just a constant that we have for the speed of light. And then v is the speed of light in material, and this is also known as velocity. And velocity is a vector that demonstrates how fast a particle is moving. And the SI units for velocity is meters per second. And n is an index of refraction. It is a measure of how much light slows down when it enters a given material. Its SI units is unitless, which makes sense because we're dividing meters per second divided by meters per second, which would just cancel out everything to give us a unitless thing. And so I move this equation around to where I would get what is the speed of light of the condensate. And condensate is basically the same thing as material, so I know that I'm looking for v, and I know that I already know c because it's a constant, and we're given n, so I just have to look for v. So first of all, this picture drawn out, this would be the speed of light in a vacuum, and I put a c for that's this variable, like the speed would be going down, and then once it hits this condensate, this material, it changes its velocity. And I changed the angles too because that's what we see in like Snell's law, but for this we're just looking at like refraction and stuff like that, or these like the speed, so we don't care about the angles, but it's just important to note. And then we know that the n is given, the index of refraction is already 1.68 times 10 to the 7. So we're given that, and then I changed this to get v, so I had to I multiplied by v to get it over here. This should be like velocity or whatever, and then once it's over here, I have v times n, and then I had to divide by n to get it over here and get v by itself. So I get v equals c over n, and so then I just plug in that equation, which would be 3.00 times 10 to the 8 meters per second divided by 1.68 times 10 to the 7, and it's unitless, so this equals 17.9 meters per second, and that's what I got up here also. So that's how fast this is going once it reaches the condensate.